Alrighty, how we doing, folks? Hope you're having a good day. Sorry I'm not there. Hopefully you can get along without me. Also, sorry about the whole you're taking a quiz today, so first half class you can review, second half you take a quiz. It's just two problems worth 15 points. Uh, that's it. That is it. So let's jump into it so I don't waste too much of your time here. How I set up the review is that you get a little practice with quadratic models. You get a little practice with exponential models, and then we do kind of like a free-for-all one. Jeez, I'm dying over here. So I already put this data in. So we're going to calculate a quadratic model for this data. We got life. Oh, that shouldn't read that. I don't know why that says life expectancy. Uh, it's my fault. I was making these pretty quick. So we want to ignore that. We're doing a quadratic model. We're going to put caret. Remember, I'm obsessed with diamonds. These are 10 randomly selected, round, clear, internally flawless diamonds. Caret weight as our explanatory, price as our response variable. And I already put that data in my calculator. So hopefully you can see my calculator now. Jeez. What's going on? I'm in beautiful Palm Springs, by the way. Hope you're having a good time. I probably have some junk in my y equals, so I'm going to go ahead and clear that. I'm going to make sure my stat plot, okay? So I just went second y equals. I want to make sure that my L2 is there instead of resid. We're going to do a residual plot at the end, but for now, let's change that. So you go down, highlight it, do second stat, brings up your lists. Go down to L2, we got L1, L2. And then if I zoom 9 is life. There's my data. Okay, I got carrots, I got price, we got all kinds of diamonds. We're living the dream. We're living the dream. Okay, so there's that. So this one asks us to run a quadratic regression. Okay, so that's all we're going to do. We're going to go stat, go over to calculate. We're going to go down to number 5, quadratic regression. I'm going to go ahead and store this in my Y1. And then if we calculate it, let's take a look at our R squared value, very high, 99.7%. Okay, so very good. Now if we zoom 9, there we go. Pretty good data. We got the last two get a little bit off, but you might expect that with diamonds. Pretty like standard practice down here with the cheaper ones, and you get some big ones and people go a little crazy. Now if I go back, ooh, it didn't save it. Well, I'm going to go back and just run the quad again, just so I can see the equation. Gosh, I should probably have a piece of paper. So the annoying bit is I'm going to go back and forth here. But this is our equation, so we're going to write this down in our other guy. Shucks, I really do need a piece of paper. Okay, hold on. I'm going to pause. Come right back. All right, so we're going to take that equation that we have, and now let's go into our guy here. We want to give the equation, you're going to write the equation down here. I'm going to actually do it on the next page so I can see it. So we're going to calculate and interpret the residual for 1.51 carats. Okay. Part B, I skipped part B. You're just sketching the scatter plot with the line. We already looked at that. You can do that. So for this part, we're going to take our equation, right, which is the old y hat. Ooh, baby. And we're going to plug in 1.51 to see what we get here. Man, this is a harder video than I was thinking here. This is actually a negative. So it's 28919. And I rounded to two decimals because we're talking about money here. So 0.61, and that's going to be times the 1.51. And then we're going to add. This was just the equation, and we're just plugging in 1.51 for x. I just took it off the old calculator. That's a 4.48 there, 0.76, okay? So that is what you're going to go ahead and plug into your calculator. And then we're going to compare that to the residual. So the original, if we look back, 1.51 is here. So the actual was 45,928. So to get the residual, we're going to do that, the actual minus the predicted. The actual, what did I say? 45,928. So that's going to be the actual. I already gave that data point to you in chat. And then we're going to subtract whatever we get for our equation here. Okay? Well, I'll pause again and we'll get back to it. All right, so here's where we're at. We did a little calculation. This was our predicted, right? So it's y, which is our actual, minus y hat, which was our equation up top here. And when you do all this on your calculator, you get 45,645 and 20 cents. So then you go ahead and you subtract and you get 282.75. So that is our residual. And if we wanted to interpret this, we would say we underpredicted. We underpredicted by 282.75, and we're talking about dollars, baby. Dollar bills, y'all. Okay. So that is what that's looking like. So then make a prediction for a diamond that is exactly 2 carats. We would do the same thing. Here's another way you could do this. Save yourself some time. So if you go in here, you can use your y equals to give you easy predictions here. If you go second trace, it brings up this calculate bit, and you can put a value in for x. So we want to put 2 carats in. Okay, and it gives us that. So if we had a 2 carat, we would be at $90,000 and 90,133.56, we'll call it. Okay, so that would be our uh, predicted price for a 2 carat diamond. The second part of that question asks, does this make sense? Okay, does this make sense? It should, right? So this was 90,133.56. Again, I'm rounding to two decimal places because we're talking about money. And yes, well, this should make sense. It's in our boundary, right? We had carats that were bigger than this. We had a couple big 3 carat diamonds. So it's in our boundary. This prediction should work. Okay? This prediction should totally work. Well, sorry, there's a lot of back and forth here, but I think I'll stop again. I'm going to put the data into the calculator, and we'll see you in a second. All right, so now we're moving on to the second question here. So this one's asking us to do an exponential. This was the life expectancy one. Now, keep in mind this data is a little bit old, so the incomes are probably lower than what they would be today. But do healthier countries tend to be wealthier countries? It's also not 20. I think I made it smaller to make it easier for you. What do we have, like 12 on there or something? Okay, so we want to just do an exponential model. Look at that model, okay? So let's take a look. Going over to the calculator, put the data in if you haven't already. I put my data in. Save you some time. Clear your y equals. Make sure you don't have a residual plot on. Okay, and then we're going to calculate. So we're going to go stat over to calculate. We're going to go down to 0, okay? Number 0 is exponential. So we're going to pop that in. Make sure you got L1, L2. I'm going to go ahead and store in my Y1. Okay, calculate. Let's look at our R squared value. Pretty good, not like amazing. So we might potentially, on a different question, run maybe a quadratic regression on here to see if it's better. But it's still in the realm of pretty good, right? 81% accurate. That has a correlation of like 90%, so pretty good. So that's our equation. I'm going to go ahead and write that down because we're going to use it later. Definitely round at least two decimals here. I guess that takes us 7.20 times 1.1 to the x, okay? So that's our equation. It's in our y equals now. If we zoom 9, there we go. So you can see our data maybe is a little messier here, right? The diamond carrots, pretty perfect competition if we're talking about economics. This could be a little messier. And you can see it goes a little bit off. So we might want to try running a quadratic on this one to see if it's a little better. But it asks us to do exponential. So there's our answer. We got that. Let's go see what other questions we got that I gave you. I think part B again is go ahead and sketch it. So if you need to do that, go ahead and do that. So let's pop in here. So again, we're going to do a very similar thing. We're going to write our equation out and we're going to plug in Mexico's life expectancy, which was 77 on the dot. Look at that nice number. So our equation was 7.2 times 1.1. And then in this case, we're going to the 77th. Again, you could plug that into your calculator and it would work. You could also go into the calculator again, and instead of plugging it all in, just go second trace, brings up the calculate button. You can pick a value. We're picking 77 for Mexico. And it expects their income to be 13,806.25. Now remember, that is our prediction. Okay. So that is our prediction. If we go back to the page here, sorry, there's so much back and forth. That's our prediction. The actual for Mexico was 11,684. So for our residual, we're going to do 11,684 minus 13,806. Sorry, this is tough. The mouse is tough today. It's fighting me. 13,806.25. Wasn't that the second time we've had a 0.25? Interesting. And then we'll go ahead and subtract those. Sorry, that was just looking really questionable. That all still looks really weird. I don't know. You're going to go ahead and subtract those and get your residual. So 11,684. A lot of back and forth. I apologize. All right, so we had 11,684 minus 13,8. Sorry, that should be an 8. 806.25. Okay, so our residual is negative 2,122.25, which is a significant difference. Okay, that is a significant difference. So we over predicted by more than $2,000 here. When their salary is only 11,000, it's a pretty big miss. So this is where you might want to be like, well, maybe we should run a different regression. And yeah, should have been a Y hat there. So this regression might not be perfect, but that's all right. This is not that different. Mexico was 77. So you can go ahead and make a prediction. We're going to do this. But instead of 77, we're going to go 77.43. And you could go ahead and have your calculator do that, and you're going to get some answer. Okay? It'll be around this, like be like 14,000 or something. Again, this data is a little old, so yeah, there we go. That's number two. Let's do uno más together. All right. I will pause one more time, hopefully. All right. So we are looking at the last problem. This is population data from North America since 1700. So in our L1, we have years since 1700. So starting 1700, 1750, 1800, et cetera, et cetera. And then we got the population of North America in millions. So two, three, seven, whatever. So we want to calculate all the regressions and look at the R squared values, put them into the graph, look at which one will be best, and we're going to pick which equation we think is best, and we will write that down, okay? So let's go over to the calculator. We're going to run all three regressions. Put the data in if you haven't yet. Again, double check that you don't have residual on. All right. And we're going to go ahead and we're going to start calculating. So we're going to go stat, calc. We're going to go to 8. Let's start with linear. Let's start with linear. I'm going to put this in y1. Remember, vars, y vars, function, y1. Let's take a look at our r squared here. 0.86. So good, not great. We're pretty good. Uh, so that's 0.86. Okay. If we zoom 9, we can see it doesn't look like it's linear data, right? So let's try another one. So we'll go stat, calc. Let's do quadratic. We'll put this one in y2. Whoops, hit the wrong thing. So we go vars, y vars, function, y2. And we'll calculate that. R squared much better, 0.9957. Okay, so quadratic looks good. Look at that, fits the data nicely. A little bit down here because you go into the negative. So if you're going to make a prediction between these dates, you'd get a negative population. So that's not great, but otherwise it does look pretty good. But if we go stat, calc, 0, bring up exponential, let's put this in our y3. Why do I keep doing that? What am I doing? What am I doing? We're going to put that in your y3. 0.98. So quadratic actually fit the data a little better. But if we zoom 9, yeah, this is a little bit of a toss-up, and this is where, like on a quiz, you might have to argue for which one you think. Quadratic fits our data better, but it goes negative here, which is a little weird. Exponential never goes negative, but it doesn't really fit the data as well. So it's kind of a toss-up. I would accept either, but you got to make a good argument for which one you chose and why. If it ever population going negative doesn't make any sense, then you probably want to stick with exponential, but quadratic fits the data better. And so if you want to predict anything closer to where we are, it's probably better. So I'm going to go with quadratic. It does go negative. That is a minus for it. So I'm going to write this equation down, but you know, it's still pretty good. So we get y equals 0.00604x squared plus negative 0.829x plus 15.78. And we're going to go ahead and I think we're making predictions, aren't we? What are we doing? What are we doing? Maybe I didn't need to write that down. What's our last question asking? I didn't even put anything on here. So we picked quadratic, and we could write that equation down. This is kind of going to be a lot to write. How many zeros do we have? 2. Now, I went pretty far on the decimal here because it could really affect it because it's so small. You kind of want to do a little bit more. Remember, we're in millions here. That's why these numbers are so small. Plus 15.78. So I think all I asked you to do, maybe I asked you to make a prediction. You guys hopefully know how to do that because I've shown you twice already. So I think the last thing I wanted to show you was residual plot. Okay, so let's go ahead and look at the calculator and do residual plot. Okay, we got our y equals. We want the quadratic one, which is in the middle. So I'm going to clear the other two. And let's double check our graph again and go zoom 9. Now we just got our quadratic in there. And to do the residual plot, we're going to go second y equals. We're going to go into plot 1. We're going to go down to L2. And we're going to go second stat. Bring up our lists. Number 7 for me is resid. So I'm going to change to that. And now if I zoom 9, we get the residual plot. Again, you can ignore if your line comes in there, just ignore it. Now we do have a little bit of a leftover pattern, so that might mean maybe we should have stuck with exponential, and that might be another thing you want to look at before picking which one you want. Yeah, but I got a little bit of a leftover pattern. Kind of makes sense, right? We were negative in here, so that's why these are so high and weird. We're negative population there. So yeah, we're a little bit off here and there. But again, it fit the data pretty nicely in the middle, in between, and towards the end. So you could see, look at our predictions here. We're pretty good. Here we're pretty good. Yeah, we struggled a little bit at the start, but it gets better as it goes on. So you would sketch that and make an argument. We would say, hey, this isn't perfect data. There's a little bit of a leftover pattern. But it overall it seemed to fit the data best. It had the best R squared, so we picked it. But it's not perfect. So there might be a better way to do your regression line out there. All right. I think that's it, folks. Hopefully you got a good review. Good luck on the quiz. Sorry that this has been a crazy everything, but with Kairos, this was the only thing that made sense. So apologies. You'll do great. 2 questions. You got it. All right. We'll see you later.